We are beginning. I apologize for certain delay due to technical reasons, as always. Right now, I want to draw your attention to that it is our third webinar in a row. It is dedicated to a cycle of experimental researches which are conducted by the scientific group made by 6 science and research institutes and schools. We are coordinator of this work, and the customer for this work is the regional gas company, which unifies 20 operators of gas distribution systems. We have rather saturated schedule agenda today. So if we shall not have time to answer all these questions, please send them to the address webinarhydrogen@gmail.com. We shall answer all your questions. And right now, I want to give the floor to Mr. Stanislav Kazda. He is the director of the Department for Strategic Development of Regional Gas Company. Without his insistence, and he's heading this project from the side of a regional gas company, I could tell that without his insistence, we would move much slower. Mr. Stanislav, you have the floor, please. Good afternoon, colleagues. Unfortunately, I do not see whether my camera is working, whether I'm sharing the video, but notwithstanding all this, that maybe the web is not working, I want to anyway welcome you on your next webinar for test for hydrogen testing program, which is ongoing already more than a year. And I want to update you with the news. Our hydrogen program has got very positive assessment from our EU colleagues, and they said they noted it is one of the most comprehensive programs in the territory of the countries belonging to European energy community. That is one point. And the second point, we have moved ahead forward a little bit regarding our experiments, because we already signed an agreement for testing the sealing materials, and after certain obstacles overcome, we launched the works for testing polyethylene materials and pipes. Our next achievement is that yesterday we managed to conclude an agreement with Czech Gas Association on experience exchange from the point of view of hydrogen and biomethane testing in distribution networks, in gas distribution networks. And next week we shall decide on specific issues with them to transfer mutually the documentation, test results, so on. It shall help us in moving ahead and promoting our tests and getting information for Ukrainian distribution systems. At the same time, want to notice we communicate with other representatives of European area regarding experience exchange and cooperation. One of the most next visits will be the visit to one of the test areas in Germany for hydrogen testing, where we will be able to see the specific achievements of our German colleagues regarding the testing of polyethylene materials and gas distribution networks. As you see, our program is moving ahead in the intended direction, and we already have tight communication with our European colleagues, and I hope this cooperation will be developed even more. That is all from my side by now. I wish you good webinar and to get useful and good information for your further work. Mr. Stanislav, we thank you a lot. And now I want to give the floor to the person who initiated basically the researches, the studies on hydrogen topics in Ukraine. Without this person, same as I was talking about Stanislav Kazda on gas distribution pipelines, and as regards Alexander Repkin, the Ukrainian hydrogen strategy initiator, we would have no progress, or we would have much less progress. Please, Alexander, you have the floor. Thank you very much, Leonid Mikhailovich. It is my special pleasure to participate today on your webinar, and even more pleasant is to see every time when we meet and discuss the topics of research, you inform me something new, some novelty every time. It proves to that the movement, the progress is there. Nobody is standing in place. And it's always pleasant, special pleasure to meet Mr. Kazda as well. I believe that he while traveling or being in EU countries a lot, that is from where he takes the inspiration and can profound understanding of this process that in those countries the energy transition already begun. I'm sure that transition will not happen without hydrogen technologies, and hydrogen technologies really means the next step towards evolution of renewable energy sources, because hydrogen technologies allow us to implement those in all strategically important areas in direction of any of hydrogen strategy in Ukraine. It's my special pleasure to cooperate with you now on hydrogen strategy. I hope that anyway an issue will be solved on the researchers from your side, and they will bring results that are provided by the commercial structure, I mean the original gas company. And also I believe that the support of our foreign partners and both USAID as well, and eventually World Bank as well, fruits, and we will be able to completely use our experience, our strive to create Ukraine more progressive in this direction. In fact, when we shall practically be working on hydrogen strategy. So I'm very thankful to you to participate today, even with written word, because the battle, as I say, of presentation already should finish, be over, and now the stage of specific and clear implementation of plans should start, of those who have been prepared to implement them in life. And direct work on places should start. Thank you very much, Leonid Mikhailович. Thank you, Alexandra. You are completely right. The memo on understanding should already be over. A real action should be started. We shouldn't lose any more time in sense of cooperation with our neighboring countries and as a whole, generally in Ukraine, because not only our foreign neighbors do need it, we need it as well. And now I want to give the floor to Mr. Gerd Müller-Seering from DBI company, a company of gas and environmental technology. It is the company we cooperate with. We are advised by them. We exchange our points of view. They can help us from the point of view of realization of our project. I am now talking about the equipment like electrolyzers and the similar equipment. Yes, we can hear you, Mr. Gert. Yeah, we can hear you. Please go on.
to have the basis for the presentation. Okay, well, then I hope that you can see my screen as well. Ah, there are two screens. Huh? Can you see the presentation? I hope so. But, today I would like to focus on the H2 companions for the distribution operators and the transmission operators. And as always, this is not work performed by myself alone, but from a team behind me. And therefore you can also see the colleagues who were involved in this work. Well, I have also prepared a little agenda for today. So very briefly, I would like to share a motivation for focusing on such compendia. Then we will have a look at the two major topics of gas distribution and gas transmission. I have a few information with me regarding H2 ready. If there's any time left, I could strive briefly some European activities. And finally, I have a summary as a conclusion for today. Well, what is the motivation to focus on this topic? And well, this is clearly to keep the climate in an acceptable condition. And well, for me, it was always very difficult to understand why this is so urgent, why we do have so few years left to improve something, especially as the infrastructure is a long-term infrastructure, and it's quite costly and difficult to change such an infrastructure. But if we look at the carbon budget, what we can emit to the atmosphere without heating our planet too much, then it's very clear that we have already emitted the largest part of what we are allowed to emit to the atmosphere in terms of CO2 equivalents. And well, what is remaining is not so much. This calculation here is already 6.5 years old, so it's clear that this piece of the cake is already reduced by now. Well, and if we look at the situation in Germany, then we can see that it took about 30 years, so from 1990 to about 2019 or 2020, to reduce approximately 350 gigatons of CO2 emissions. And if you look at our goals for the future, well, then we have to recognize that we have another 30 years towards climate neutrality. And if you see how steep this here is, then it's clear this is a very challenging task. But is this task challenging enough, or if this reduction is it fast enough? And well, if you look at some water conditions, for example, that we try to stay below 1.6 or 1.75 centigrade degrees warming, and if we consider that Germany has about 1.1% of the world population, well, then we calculate that only another 7.3 gigatons of CO2 equivalents should be emitted. And if we jump shortly back, this is about 10 years. And well, what you can see here, that's what we have on climate goals. And if we look at the improvement of the protection of the climate protection law, which has happened in this year, well, then you can see that this is an improvement, but still not enough if we would like to reduce our greenhouse gas emissions to the share what is our share considering to the world population we represent. It's challenging, and even if it's more challenging, it's still not enough in terms of fair climate goals. Well, however, we need to translate it into actions, and the question is, what is to do? And well, our suggestion is to say, well, at first we need a fuel switch. We need to go from coal to gas, from oil to gas, and from diesel to compressed natural gas and liquefied natural gas, because these are fast and effective actions that are quite cheap. And at the next level, we need to change the content of the gas. So we need to go from natural gas to biogas and to syngas, and of course to hydrogen. Well, and the last step is then the sector coupling, to bring in together the different sectors in order to really achieve the climate goals. This is quite a challenging task, and I have here another diagram which just should let you know that up to now we were focusing very much on this area here, so the power production. And yes, the power production, power generation is now by approximately 50% is based on solar and wind power, which is great. But if you look at the larger parts of our energy consumption, this is gas and this is oil, then it's clear that it's great that we have now about 10% green energy, but the larger part here, these are the molecules. And it's quite a challenge to make all these molecules green. And it's also clear that this cannot be achieved via electrons only, and not only be achieved by the power grid, because this energy here is transported and distributed by the power grid, this here by the gas grid, and this here, well, via oil, gasoline, diesel. So it's clear we need different infrastructures, and we need to prepare ourselves to make the natural gas grid ready for hydrogen and other green gases. This is possible, and well, I have presented this last time as well. Therefore, very briefly, we made a very rough calculation based on the assets we have in Germany in the gas grid, and we came up with the conclusion that with about 45 billion euros, we can make sure that sufficiently green gas is transported through the existing natural gas grid. So this is well, possible. The question is how we need to adapt our existing natural gas system. And well, to make that clear and to help the grid operators with this task, we have developed this compendium for gas distribution networks. It was initially a joint industry project paid by E.ON, TÜGA, and about 10 others DSOs. And currently it's sponsored by DVGW, by the colleagues from Austria, and from Switzerland, so by the 3 different associations for gas. Well, what is the compendium? This is a condensed book of knowledge where the existing knowledge on how much hydrogen can be accepted in the existing infrastructure is brought together. We have a different or a special structure. So we have a short report explaining everything, and we have these fact sheets or profiles where you can find for every component, and that's important. So for a piece of pipe, for a valve, for a gas stop valve, for a pressure regulator, and so on. A very brief overview about the material. Is it fine for hydrogen? The function, so does it work with hydrogen? And the codes and standards. Is it allowed by current codes and standards to use a certain percentage of hydrogen for this component? Well, and then you find a short explanation and also the sources, of course. Beyond that, we prepared the same for materials, for example, steels, plastic pipes, and rubber materials, which you can find very often in the gas infrastructure. And we also identified, we call them system fact sheets, for example, regarding the authorization or explosion documents or capacity calculations because they are system relevant. So we put together the knowledge for that as well. And in total overview, you can see for the gas distribution system, for the house connections, and also for the end use, the opportunities which is possible right now, and where adaptation, yellow, is needed, and where we have, well, larger adaptations or renewal needed in order to prepare the system for higher hydrogen concentrations. Well, and this was about the gas distribution grids, especially on the component level. And the next step was to say, well, a component is great, but I'm not only interested in a valve, I'm interested in a special valve of a certain manufacturer and a special type of valve, because this is maybe the valve I have in the grid. And I would like to know, especially for this valve, well, how many hydrogen percentages this valve can accept. And so we further broadened the level of knowledge. So we talked to the manufacturers, and we developed together with them for a lot of single products the same. So a fact sheet, but not anymore based on a component, but on a product. And well, the functionality is more or less the same. And well, this was the first step, and we started this work about 3.5 years ago. And well, then it was clear that we need the same information for the gas transmission networks. And well, so again, we went for this fact sheet system because it's very handy and very easy to read, and it's helping the people in the companies to decide quickly if the products are suitable for hydrogen or not. Yeah. What else? We focused here on everything what is green. I'm sorry that I was not able to translate everything, but this here is the transmission. So we have here the compressor stations. We have here the gas pressure regulation stations in the transmission system. Here is a special component which is a type of a damper. Then we have the pressure regulation between transport and distribution. We have here the PIC launchers. Excluded are the gas turbines and the underground storages. And well, for mainly these components here on the transmission system, well, the same work was done. And also for the materials, because steel in the transmission is significantly different, not in terms only of the steel, but also from the operational conditions, and therefore this was evaluated differently. So for a 4-bar distribution pipelines, 100% hydrogen is no problem, but for an 80-bar transmission pipeline, which has certain pressure swings, it could be challenging. Well, this is the result. So we have the same structure as you already know from the gas distribution. And that's all about the compendia. And I know that the time is almost through. Therefore, I will give only a very short overview about H2 Ready. This is another step ahead. So the compendia, we're focusing on the existing infrastructure, and H2 Ready is focusing on new infrastructure. So if you buy a valve or a house connection or something else today, then you would like to know, is this product fit for hydrogen? And therefore we developed an H2 Ready trademark with a certain testing procedure behind. And if a manufacturer is tested according to this testing procedure, we can say with a very high certainty, yes, this product is ready for hydrogen. And this should ensure that new infrastructure that is built now or in the future is already prepared for the hydrogen. And so this is just a trademark, and then in terms of a security for the grid operator that he is buying the right components. What else? In Europe, there's a lot of things on the way. We have an existing macro gas infographic. You know that maybe it looks like that here, also in bars, and with a lot of knowledge behind. We recognize that hydrogen is now, well, in the heads, but not necessarily in the heating market and in the blending, and also not so much seen in the gas distribution. And therefore we thought, well, we need a proof of a safe, of a cost efficient transformation, that we are able to do that safe and cost efficient. And therefore the working group is now focusing on the mitigation and cost analysis and on H2 safety and risk. And well, maybe I can share with you more information on that next time. Well, the colleagues from SEN and Senelec, they are also working on the topic and preparing pre-normative research. And this is now taking over by Georg. So there's a project running on those topics here. And again, here the existing knowledge is investigated, aiming to say, well, in which areas we still need to do pre-normative research before we can really start with hydrogen. We as DBI and GERB, we have also a little network which called HITNet and brings together latest information on hydrogen in the natural gas system. Well, conclusions before Leonid is pushing me to finalize everything. Well, it's clear we are able to fulfill the 2 centigrade degree aim of the Paris Agreement. That's possible in the natural gas system, but we need to prepare our system for the hydrogen. So it needs to be H2 ready. For that, we have this registered trademark developed together with DBW. Beyond that, we have brought together knowledge on the components and products for the distribution, and only on the components right now for the transmission pipelines. We are also focusing on the underground storages. So a very first project is running with 3 associations, DBW, INES, and BVEG, on this topic. And well, the trademark is, of course, helping the manufacturers and the grid operators. Finally, I would say we can achieve this goal, but there's a lot of things to do before we are really ready to accommodate high concentrations of hydrogen in the system. But we need to do that very quickly, otherwise it's too late for the climate and especially also for us as the gas industry. Well, so thank you for listening, and if you have any questions, please let me know.
Many thanks for your the question will be in the end of other reporting of other speakers.
Okay. Well, then I will wait patiently.
Шановні колеги, зараз
Dear colleagues, I want to comment on the presentation of Gert. I want to say the following. It was very interesting presentation. We had listened and seen his presentation on the 6th gas forum. And now we plan that with the results of new materials and new researches, he will take part in the 7th gas forum as well, which will take place 27th, 28th October this year. Дуже дякуємо, Герт.
Thank you much. I will try to appointments, but I will try to jump in for the questions.
Thank you. Зараз я хочу надати.
Now I want to give the floor to the director of the Institute of Gas, Mr. Gennady Zhuk. We cooperate with them on several directions connected with our projects. First area is the study on the heating devices, heating appliances. This research is almost completed according to our plan. Those are gas ovens, boilers, water heaters. And now, together with we work on the research of sealant materials. And we have another work ahead of us connected with gas regulatory points of the distribution systems. You have the floor, Mr. Gennady. Good afternoon, dear colleagues. Do you hear me well? Thank you. welcome all of you on behalf of the Institute of Gas of the National Academy of Science of Ukraine. I try to fit in that time talking about our achievements, our research, and our potential, eventual research, what we can develop technologically in the sense of hydrogen direction. Okay, I see my presentation is already on. So I want to tell, can we get next slide? Thank you. We are moving towards the direction the whole Ukraine is moving and our government is moving. Ukraine ratified the Paris Agreement in 2016. In 2020, Ukraine supported the European Green Deal. And just recently, a meeting of the Council on Security, Defense and Security took place, and the decree of the President of Ukraine on the national security, on challenges and threats to Ukraine's national security in the environmental sphere and priority measures to centralize them was adopted. We are moving towards this direction. We develop the alternative fuels and hydrogen technologies as well. I will talk obviously about the technologies exactly in the sense of research of hydrogen. But I'll talk more about the potential capacity, possibilities of our institute based upon the already developed technologies for use of alternative fuels, traditional conventional fuels, and what else can be developed in this direction. So to move towards hydrogen, low carbon energy. First of all, our technologies traditionally were connected with natural gas, with its use. And now I believe that exactly the mixtures of natural gas with hydrogen is a realistic and most prospective direction at the current stage, talking about the transition to low carbon power, to carbon free energy. First of all, our institute developed a series of industrial boilers working on gas as a fuel. Obviously, within the framework of using gas and hydrogen mixtures, we can now update these boilers, modernize them to use gas, natural gas and hydrogen mixtures to determine relevant parameters of use. Same regards the use of gas and hydrogen mixtures and natural gas for maneuverable generation, for production of electricity on gas and hydrogen mixtures, and cogeneration, meaning simultaneous production of heat, and to cover the peak loads to balance this in peak hours in the power system using these kinds of fuel. Also, traditionally, we are dealing with use of gases in transport means, alternative also forms of gas, different from natural gas, and mainly transported by gas pipelines, meaning liquefied and compressed gas. We developed the technologies of use of CNG and LNG. We have been the first leading institute in the former Soviet Union on use of compressed gas in transport means. The use of liquefied methane means these technologies will be used in the area of gas and hydrogen mixtures. And in the use of pure hydrogen, what we did already in the sense of using alternative gaseous fuels, and what direction can there be on introduction of hydrogen, pure hydrogen use? First of all, how can we use it? Basically, the hydrogen, meaning green hydrogen, the hydrogen obtained from hydrocarbons, also the biogas. The biogas can be not only the mixture of methane plus CO2, but also hydrogen plus CO2, and also the generator gas having H2 in its content, and also combustion of other alternative gaseous fuels in boilers with the aim to reduce harmful emissions to the atmosphere. We have a rich experience on the use of landfill gas. Already 7 landfill gas production and utilization projects have been implemented in Ukraine. Our developments, our technologies have been used within those projects. Based upon those projects, the reduction of GNH gases made about more than 500,000 tons of carbon dioxide equivalent. Means we have practical experience of use of gas mixtures in internal combustion agents where the share of methane makes even less than 30%. In such a way, we have a good perspective for the use of hydrogen plus gas or pure hydrogen in internal combustion engines. A little bit more in detail, it will be talking about this our head of the relevant group. We'll talk in the video which will be launched after my presentation. And this group is now dealing with the development of the relevant technologies on hydrogen use. First of all, it goes about the use of biogas or future use of hydrogen or gas plus hydrogen mixtures in the boilers. Also talking about gas separation from mixtures to separate CO2 in the objects, in the facilities which now are using our technologies. Pure hydrogen or gas plus hydrogen mixtures could be used on those facilities as well. I will dwell a little bit on this. It's going Professor Soroka Boris already delivered on the practical experiments on the use of hydrogen in domestic appliances. Talking about domestic gas ovens and water heating boilers, certain results have been achieved, and it was shown that up to 50% of hydrogen could be used in gas plus hydrogen mixtures to make work these appliances, these devices. This is a description of the experiments I was mentioning about. Also, we shall be glad to be involved in the use of water, of hydrogen containing mixtures, for example, the biogas or other kind of gases from the point of view of assess the industrial emissions, how the use of these alternative gaseous fuels will impact on reduction of emissions by the industrial systems. In our institute, we do have a number of devices in the laboratory. We have a gas analytical laboratory based on Agilent 6890N gas chromatograph, and the software system gas CondNafta, which simulates, which models the use of gas plus hydrogen mixtures with different parameters and talks about the relevant results. To conclude with, I would like to tell that I see the role of the National Academy of Science of Ukraine and Gas Institute to help and enable the real transition to low carbon energy for Ukraine. So we have big plans. The Ukrainian government, our country has big plans together with also with our international partners for the use of hydrogen. But first of all, these plans have to be assured with real technologies. The natural gas mixed with hydrogen should be considered as transition fuel, including its use for electricity generation, maneuverability in liquid and also compressed form. Talking about replacement of fossil fuels, to replace the natural gas, it can be made by biogas, 8 BCM annually, generator gas, about 5 BCM annually, and hydrogen, about 3 BCM a year. I mean, in the equivalent to of natural gas. You see with green color, are shown the guaranteed amounts of reduction of greenhouse gas emissions. To conclude with, I would like to say that we are conducting research and we are creating technologies for production, preparation, and use of natural gas and alternative gases fuels, which will prevent climate change in compliance with government decisions and international obligations of Ukraine. And now I'd like to launch the video. I will repeat once more. Our head of the group on use of alternative fuels in the engines, Oleg Stepanovich Verbovsky, will talk about the practical experiments on hydrogen topic, on hydrogen use, and more exactly how the sealants of pipes are behaving, the patterns of their behavior in transmission and storage of hydrogen, and how the pipes themselves intended to transport hydrogen are behaving. If there will be any questions, please, you're welcome to ask them. I thank you, Leonid Mikhailovich, for inviting me to this webinar. Thank you, Mr. Gennady, and now we shall listen to the video and watch the video. There is no sound. Unfortunately. No video sound is broadcasted.
Інститут газу Національної академії наук.
The Gas Institute of the National Academy of Sciences of Ukraine has been dealing with the use of alternative gaseous fuels for internal combustion engines for almost 35 years. During this time, the Institute developed technologies for conversion of diesel engines into gas diesel and gas reciprocating engines, and also the technology of preparation of putting any burning gas into fuel condition was also developed. Based on these two technologies, the Institute is able to produce gas diesel and gas piston power plants. Should be said that during this time, almost 300 units of such power plants were built, and they are operated at the facilities in 5 countries around the world. The capacity of these power plants is from 16 to 700 kilowatts. Below are photos of some of these power plants. Gas Institute has its own laboratory for gas engines. This laboratory exists for almost 30 years and has all the necessary equipment for testing the combustion of gas-air mixtures in internal combustion engines. The unit of 30 kilowatts of electric power has the plant, the unit for utilization of exhaust gases. Thus, we can test here the joint generation of electrical and thermal energy, heat energy from alternative gases. The stand is equipped with an installation for air gasification of various wastes. And from this installation, we supply air gasification gas to the engine for conduction of researches. So the engine can run not only on alternative gases, but also on conventional gases, natural gas and propane butane. This year, the Institute began a series of researches to study the effects of hydrogen and mixture of hydrogen and natural gas on gas pipelines, materials, and sealants, which are traditionally used in gas transmission. Now the Institute is building an experimental stand to realize these studies. We are now near the building of the center where this stand will be located. At present, the building is by 80% complete. Here, a laboratory base required for research will be located. Also, polyethylene pipes already are available here, which have been in use for 10 to 15 years. Over time, they will be laid into a special trench where research will be conducted. This premise of the experimental stand has a trench in which 16-meter-long polyethylene pipes will be laid, both new and used ones, and the time of holding these pipes here will be 12 months. Every 3 months, we will conduct the relevant analysis of the impact of the effects of hydrogen and mixture of hydrogen and natural gas on the materials of these polyethylene pipes, which are laid in these trenches. Thank you, dear source, for your presentation. I hope that after several webinars, you'll be able to talk already on the results on how the metal pipes are behaving and how the polyethylene pipes are behaving with hydrogen, or when transporting gas plus hydrogen mixtures. Now I won't give the floor to the Doctor of Scientific Sciences, Mr. Grigory Nikofirchin, who is heading and managing the researches of Kyiv Research Institute for Material. Thank you. I welcome everybody, and now I will try to share my presentation. Can you see it? Yes, the presentation is online. Okay, then you can hear me. The presentation is shared. We can start. The name of the presentation is Investigation of the Methodology of Impact of Hydrogen Transportation by Gas Distribution Network. The essence of the methodology, I will be very briefly talking about it. The object of research. The pipes with diameter 159 millimeters and the thickness of 4 millimeters, we selected that type of pipes of relevantly small diameter compared to main pipelines, transmission pipelines. And also, what are the most dangerous, hazardous elements of those pipes? Those are welded joints and 90 degrees elbows. We compare the initial condition of new pipes and the pipes which have been in operation for about up to 50 years. So we compare the new and the used pipes. That is how we shall name them further on. And here I want to underscore some basic points of our methodology, of our method. There are three of them. First one, holding witness standard of test area in a pipe with hydrogen or gas hydrogen mixture from 3 months. The maximum duration of our project is about 18 months, it's up to 2 years. But basically, we can test those pipes, those materials up to 3 years. In Bohorodichany test area in Ivano-Frankivsk division of regional gas company, they built up a good test site. This photo shows the image of the pipe on the other side. One pipe is filled with pure hydrogen or hydrogen plus gas mixture, and that is where our sample can be placed inside those pipes and be tested. They can be changed by the exposure to this hydrogen during this time. So these conditions are very close to the operation conditions. Second point, for determination of mechanical properties, we use the samples which will cut across the axis of the pipe, the transversal cut axis. It is basic because the pipe is of small diameter, it is a thin wall pipe. So we have to take the samples in the longitudinal direction. It is quite easy to do. Our practice of the study of degradation of transit pipe materials proves that we have to study longitudinal samples. They are much more subject to degradation than transverse ones. You see, this is a sample of this pipe. The destruction of this pipe will first of all happen along the fibers of rolling of the hot rolling. So we use this point. We had very great difficulty in the cut out of the samples in these longitudinal directions. It was very difficult to get such samples, but we passed successfully that step. And you can see the samples for tensile test for determination of strength and ductility characteristics. And the third specific, the thickness of the samples is 1.2 millimeters. Very small thickness based upon that the hydrogenation happens from the surface and it might be not very deep. So to measure the effect of this hydrogenation, we have to have a minimum thickness of the sample. It is the third specific point of our research to have the best assessment, and it will give its result for sure. We use two ways of hydrogenation. In laboratory conditions, we have electrochemical hydrogenation, and the second way in the test site. You see these very thin samples. You see the device for ductility testing. We impose the initial tensile strengths for those samples, and such blocks are inserted inside the pipe. starting from 3 months, these samples are held under tensile force. And after hydrogenation of the samples, we can expect for this destructive force of hydrogen, and we could measure it. So on top of tensile stress, we also provide crack resistance. The crack resistance is defined when we see the start of crack appearance. We are not interested here in having the integral characteristic. So very small thickness should be there. In this case, it's everything okay. But if we cannot achieve the very small thickness, then we have just to capture the local characteristics of crack initiation. When we are talking about hydrogenation, which happens not at very deep thickness, and this initiating crack can show the effect of hydrogen. This is the specifics of our use of crack resistance testing. Those have been the methods. And now I want to show you the first results achieved by us. This shows the properties of strength and ductility of the samples in the initial new and in the used state of the pipes. Main characteristics of ductility. Delta means the extraction, and another sigma means the compression. We see the initial new pipes and used pipes. We see that ductility characteristics are relatively lower after being used. It could be explained by data bias or by data deviation. No, you see the strength also reduced. If it would be just data dissipation, then lower strength would correlate with lower ductility. It is the golden rule for such tests. But here we have lower ductility and lower strength both. It proves to a basic feature of continuous degradation of steels, plasticity, ductility, degradation of steels. Also, we defined the impact strength of steels. We, on the results of this test, we built up the frailty or fragility curves. This impact strength is equal to 0.1. It is for a new pipe, and below we have the used. This the used impact strength the used pipe we see on the lower, it produces kind of a first alarm bell. For the first time at all, we use the materials in such an old state, 50-year-old pipes. We use these materials, and we want to put hydrogen there. I don't want to scare off nobody. These pipes have been working up to now, maybe let them work further on as well, but there is also another detail. We have the data here. We measured the number of hydrogen, the amount of hydrogen inside the metal. For new metal, it was 0.1 ppm. For the used pipes, it was 0.5 ppm, 5 times more. So we believe this degradation of metal with fragile destruction proves to that even for the gas pipelines, there is hydrogenation from inside surface of the pipe. And this result of brittlement is the result of the joint effect of hydrogen and pressure. So this effect takes place not when will not be seen only when we put hydrogen. It is already present in those pipes. If hydrogen use Now the question is, will hydrogen use enhance, make even worse this problem? No, we have to give answer to this question. Now we took those samples, which determine the strength and ductility in the laboratory conditions. We made very moderate hydrogenation. We saw that the strength is not impacted by this hydrogenation. Now the ductility. To the left, here I show it with arrow, it doesn't impact on new pipe, the hydrogenation. And to the right, that is the used pipe. The used metal is has lower ductility. When we give higher hydrogenation, we have a very big drop of ductility. Here you see for used pipe, the effect is even stronger. It is not unusual. We know about it, but I want to underline on that if we have to produce some recommendation in the guideline, in the normative document, we have to talk about relative narrowing, and we have to show that relative narrowing is more sensitive parameters than talking about hydrogen brittlement than relative relative degradation. So we have got first results on one side, how the hydrogenation impacts on new induced materials. On the other side, we have already put the first samples into these test sites inside those pipes for 3 months duration and for 18 months duration. 3 months term will end in September. In September already we shall take out those samples which are under tensile forces under load now, and we shall analyze, we shall measure with our research whether the parameters, the properties of metal change or no, but we have to at once take into account that there is the so-called diffusing hydrogen and the trap contained hydrogen. When the metal is without load, without tensile force, there is trapped hydrogen. That 0.1 ppm of hydrogen, that is the trapped hydrogen, and the diffusive hydrogen is passing through the metal. So this pipe are with liquid nitrogen, and our test will bring this pipe into our lab, and we shall take out the samples immediately before measuring them to determine, to measure both diffusion hydrogen and trapped hydrogen. I believe the conclusions already have been said in the previous presentation. I will not read them out for you. Thank you for your attention. Thank you very much, Mr. Grigori. And we now pass to another specific study, concrete study, which, by the way, is conducted in cooperation by two institutes, the Gas Institute, about which Mr. Verbowski already talked a little bit, preparation of stand. And now I want to give the floor to Maxim Kovalchuk from the Institute of Electric Welding, because the study of polyethylene pipe is provided in parallel by these two institutes. Mr. Kovalchuk, you have the floor. Hello, good afternoon, all the present. First of all, I want to thank Boris Mikhailovich for this invitation, and for second, I would like to ask your permission to talk in Russian, upon your permission. Please, you may talk in English as well. What is best for you? Can you see my screen? Yes, we can see the screen. It will talk about the research of use of hydrogen and its mixtures on the polyethylene materials. This study There have been very little number of those studies, and they have been very short term. They are informative, but we cannot forecast a durable behavior of material on the hydrogen impact. There have been no long-term studies up to now. This is the topic. The topic on the existing technologies of storage and transportation of hydrogen, and the laminated structures are used. Why so? Because the impact of hydrogen, the diffusion of hydrogen is obstacled by very abrupt changes of microstructure on the borders of separate layers. There are three types, different types of such structures. In the relevant layer, there is diffusion of hydrogen. The second point is three layers composition: metal, plastic, HDP, metal HDP. Another point is where there is also some liquid in one of the layers. We have very little information about the results of research, and also it is just a commercial secret, banally, and the inventor uses its benefits. Among the studies available, the first table to the right shows main parameters which will be interesting for us: permeability, diffusion, and solubility. On the figure 3 for a dynamic mechanical thermoanalysis, here we can see how the test was conducted. A sample of materials 6 3 mm was saturated with certain concentration of hydrogen, and we see on the graph no changes of tan delta. In the polymeric material science is the glass and temperature. And also we see the substantial change of elasticity modulus. It is very interesting, the retention, no change of tan delta, because it means no phase modifications in the material, and especially the lack of the changes in the amorphous phase of the material. The second phase, the crystalline phase, plays a function of the barrier, to say so. To the right, on the diagram of the density of material in this left column of polyethylene, we see no significant changes, but anyway, there are there, especially it could be said on the summarizing table under the diagram. We can see that the volume of material changes in certain time after of hydrogen exposure. It proves to that there is a decompression of the material which influences its morphology. It was observed in certain researches. One of those when the polyethylene material was placed into the hydrogen up to 30 times in cycles, and they found that increase of number of cycles, there is an increase in microcracks. We already see that there is an impact on morphology due to decompression. The available data on thermogravimetric analysis, no volatile compounds were found. Samples were studied which were tested for 1 week. We can talk about some long-term studies. Results could be considered. Now talking about the strengths, we see the stress strain curves diagram, and it shows that the material after certain cycles of hydrogen is becoming stronger. But this is a very short-term result. So these data are low informative. We can just understand that under pressure, this deformation is serving to improve the strengthening materials, and at the same time, the embrittlement of this material happens simultaneously. Why cannot we judge on certain long-term strengths using this data? I will give you an example. In our research study, we have different types of polyethylene, those which were underground, which were under pressure. For all the samples, underground and other samples, we have seen this initial strengthening after hydrogenation. It was such a residual cross-linking of polyethylene. But with time, the strength characteristics which we conducted this experiment in during 3 years. For first few months, there have been strengthening. Then the strength parameters came back to the initial, to the baselines, and other parameters even deteriorated. Also, I would notice then there are no currently research of the pipes which have been already exposed to a natural gas. With X-ray structural analysis of the samples, no changes have been noticed. We had this basic distribution I was talking about later, earlier. Also, I would like separately say that from the researches, the most long-term researches which ever have been passed in the world for 1 week, there are no long-term researches, so we cannot clearly say about it, whether the hydrogen impacts polyethylene pipes or no. We have what we have, we can judge on that only. So for further studies, it was recommended to use the materials which were used for more than 15 years. The polyethylene, which pipes through which natural gas was already transmitted. The new polyethylene with no exposure to natural gas and more dense polyethylene. The hydrogenation concentration are recommended to be used during the test. The pure hydrogen and the mix of hydrogen with natural gas 20 by 80%. And the control points in this research will be at baseline point, and there will be database accumulated and correlated on the next points, 3, 6 months, 12, 24, and 36 months. The impact of hydrogenation will be used by standard methods of polyethylene material used. Those methods are correlating between them. And one method is explaining the behavior of 3 other parameters. The use of electronic optic microscopy to study the morphology of the material for micro cracks, standardized strength use with continuous internal pressure for resistance to internal pressure, Fourier transform infrared spectroscopy is a structural analysis which will give us the results upon which we can be able to judge upon this transition of phases. The historical amorphous, I'll remind you that the diffusion of hydrogen into polyethylene happens exactly during the amorphous phase. We'll assess whether such a ratio wouldn't change or no. And from that, we can judge on the increase or decrease of the parameter of materials. Differential scanning colorimetry will be conducted to define change of thermal capacity material. And thermogravimetric analysis is another study which is replaceable with other materials, which will also allow to judge on thermochemical resistance of this material and to measure strength parameters, strength properties of this material based upon the temperature change. This is a comprehensive, complex study of polyethylene pipes. I tried to be brief, not to take much time. So thank you for your attention. I'll be happy to answer the questions. Thank you, Mr. Maxim. And we shall have now the last event of our short webinar. We shall see the video by a regional gas company, and thereafter, the completion of our short webinar will take place. Due to shortage of time, we'll not be able to answer right now directly your questions. I emphasize once more, please send all of your questions to the email address I mentioned in the beginning, and we shall answer all of your questions. And now, colleagues, I ask you to launch the video from RGC.
Critical condition. Does the existing gas infrastructure have a future? Regional gas companies seek to transform the outdated gas distribution system into a modern and efficient one, and is consistently implementing pilot redesign projects. Redesign is intended to transform old gas networks into modern and efficient ones. It optimizes excess capacity and emergency sections. Over the past 3 years, 38 such projects have been implemented in 16 regions. How to deliver clean energy to customers. An important part of RGC Network's redesign is to get them ready to work with biomethane and hydrogen. RGC has built a portfolio of its own Green Deal programs, for instance, hydrogen and biomethane projects. 5 hydrogen test sites have been built and commenced for practical and scientific experiments. At these test sites, RGC experts, together with the scientists from the major research and development institutes, study the impact of hydrogen on the network and gas equipment. Test sites will allow to create promising hydrogen valleys in Ukraine, for instance, hydrogen energy hubs. RGC Biomethane Project will provide access for biomethane to gas distribution networks. It will stimulate the development of biomethane plants and local networks capable of working with multiple gas sources. These biomethane clusters have the potential equal to 8 billion cubic meters of green gas per year. Comprehensive redesign, for instance, improvement of networks and getting them ready to work with synthetic gases, is intended to create infrastructure that will help the country move forward. What trends and challenges are shaping the future of Ukraine's energy infrastructure?
Шановні
Dear colleagues, on this we wrap up our short webinar. Due to shortage of time, I repeat, we'll send you written answers, and we shall put on our website, post on our website, the answers to the questions which already arrived or still shall arrive. I would like now to break certain interruption to October. And since October, we shall continue our webinars. I want to thank all the participants. Although we'll have an interruption in the webinars, but there will be no break, no interruption in the experiments. They are continued. So we're planning it. In 2023, 2 already achieve experimental transmission of gas plus hydrogen mixtures to certain small settlements and small companies. It's very important talking about industrial companies, first of all, to talking about the metallurgy, cement production, fertilizers production, because these industries of Ukraine, which are export-oriented, very soon they will encounter the additional carbon tax, border carbon tax. So the perspective of supplying pure hydrogen or hydrogen plus gas mixtures, it is really can be very interesting and motivating for them from the economic point of view. I want to thank everybody for their participation and see you next time. I thank all the participants and all the speakers for participating in this webinar. See you. See you.